Hey, what's going on, folks? It's Mike here. Welcome to the next lesson in our modern C++ series. In this lesson, we're going to continue talking about standard template library data structures, this time talking about the standard map. Now, for those who've been watching this series, we've covered the standard set, which was an ordered data structure. So standard map's going to be related in that it is an ordered data structure, but it's an ordered associative container. So with that said, let's go ahead and look at the definition on CPP reference, and then we'll go ahead and do a little bit of examples with maps so you understand how to use it in C++. So what I've got here, again, we'll just go ahead and look on CPP reference and on the containers library, and we'll look at map here. Now, map here, as mentioned, is a sorted associative container. So that means the actual data is going to be sorted, and it's associative because it is a set of key and value pairs. So just looking at the templated data structure here, you can see that we need to provide a key. That's going to be our index into the data structure, and then the type or the value that is actually stored there. And again, anytime we have these sort of key value pair data structures, we need to think about the underlying assumptions with the data structure. Again, if it's going to be sorted, that means we're probably using some sort of tree-like data structure to store it. And in fact, that's usually the case here with the map implementation. So it's using something known as a red-black tree. In fact, it might actually be useful at this moment for us to just open up a tab and look at some source code here. And if we actually look at the implementation here, if I look for tree here, we can see that there is a tree set up here. And I think if I search for red, black tree, you can find that there's usually some sort of red-black tree here. Now, what is that tree data structure? Again, not as important that you look at this data or this actual code of the data structure, although it is nice to go through eventually. Just want to show you that this is in fact an accurate representation. So here's a red-black tree. Again, very similar to what we talked about with the set data structure previously, but it is some data structure. So if we label our map here, which is again a key value data structure. So it's associative, meaning we're going to look at the key in order to determine what the value is. We are keeping order by using this balanced tree here. So let's go ahead and actually look at this picture here. So 13 would be the top node, and then everything that's going to the left is going to be smaller, values like 8, for instance, and then everything to the right is going to be larger. Again, depending on how you sort this data structure, you could flip the order if you want, but that's the basic idea. And then what I like to do when I do trees, especially if they're sorted, is I just kind of draw columns down here. And then if you think about just dragging the nodes all the way down here, so as you would iterate through this data structure, you get the sorted order here, okay, as you traverse the actual tree here. So that's sort of from your algorithms class, you can think about how to actually traverse this tree, going to the left as far as possible, and then kind of going to the right. You know, that would be the idea to get the order here, okay? And then, of course, the 8 here would be an index or the key and retrieve you some information. So maybe these are unique identifiers of some sort. So, you know, person number 8, and then you get their actual structure for whatever data you want. Okay, so that's the idea. That's the underlying data structure. That's what you need to know. Now, anytime you think tree, you usually think, and this is highlighted here in the actual CPP reference here, you're thinking logarithmic complexity, because in order to get to one of these values, you need to actually traverse this tree downwards a logarithmic number of times. So this is a balanced tree, binary tree, so it usually means log base 2 here. So that is the complexity of most of the operations for inserting new nodes, removing nodes, and retrieving information. Okay, so that's usually pretty accurate. And we will cover, just like with set, there was unordered set, there's also unordered map. So make sure you subscribe so you don't miss that. But we will talk about that actual data structure and how it might compare in the performance versus map. Now, because this is an ordered data structure, that means you can provide the comparison operator here, or provide the template parameter for performing a compare. And you'll have to do that if you create a custom data structure, for instance. And we've looked at that with our set series where we covered that earlier. But anyways, you have to do the same thing with maps here. And of course, if you want to provide your own allocator, most of the STL data structures, if not all, provide some mechanism to do that. All right, so with that said, let's go ahead and start taking a look at map, just how to create one, and then we'll look at some of the functions here that are going to be relatively familiar to all the other STL. So element access, iterators, some of the modifiers, and how to look up data and so on. So anyways, let's go ahead and start towards the top here. And let's go ahead and create our map. I've already included the map header and strings because we might want to play around with strings a little bit. And let's just go ahead and look at how to insert a node. Now, one of the things that you'll notice here, let's go ahead and open up this operator, the index operator, is that it allows for access or insertion of specific elements. Okay, so let's go ahead and look at how this works here. And I'm going to go ahead down to, well, let's just go ahead and start with an example here. Now, the first thing I'm going to do here in order to create my map here, standard map, is provide the key. Let's go ahead and use strings for our key here, just to get things started here. And then we'll go ahead and use a custom data structure here. Now I'm just going to use, I'm going to create something called a vertex, or actually let's create something called a an edge. That'll work a little bit better. I just want something that's, you know, non-trivial here. Okay, so an edge would be like if I have a triangle here, the edges in between them consists of two floating point values here that will describe, or actually two indexes into a triangle here. Okay, so these could be things like vertex 0, vertex 1, vertex 2. So the edge would consist of 0 and 1. Okay, so that's the idea here. Let's go ahead and just create that edge data structure. I'm going to make it a struct edge. And then we'll go ahead and just create the indices here. So let's use unsigned longs for those. And I'll just call the first vertex and the second vertex. Doesn't really matter. I just want to show you having some different data structures here. Okay. And then we'll just go ahead and call this my map here. Now, why you'd want to, you know, index these into a string into this data structure, who knows? But I just want to do something that's not too trivial here. So anyways, using the access operator here, you can see from the example here, this will, if this element doesn't exist when we use the access operator, it'll create it, and if it does exist, it will update it. Okay, so as is shown there. So let's go ahead and do this here. So I'll use my map, and let's go ahead and just call this edge 1 here, and we'll go ahead and set it equal to, we'll create a new edge here, and just some values 0 and 0. How about that here? Okay, so let's go ahead and start with this. I'll compile it. I'm using C++20 here because we'll look at some of the things like contains, which are in C++20, which will be useful. And we can see that that works here. Okay. And then let's go ahead and do the same thing here. Let's do my map here, edge 1 again. And then I'm just going to go ahead and update it here with 1 and 1. Okay. So if I go ahead and print out my map here, and let's just go ahead and see how we print it out by accessing it. My map, edge 1 here. Well, first and foremost, before we even get to updating it here, let's see if this prints out anything here. Okay, let's see what actually happens. Now we have our custom data structure, so we don't have a way to handle this operator here. So let's go ahead and overload this so that we can print out our edges. That'll make things just a little bit easier to see. And I think it's useful to debug. I usually have to look up these things. So I'll just toss in the first Google search on this. You know, if you want the Microsoft article here, that's what, you know, I'll usually reference these types of things, or we can find them on CPP reference. But we need the OStream operator here and operator here. And we take in the OS stream. And then whatever our data type is that we're not modifying, so that's why we pass it in as const. And I'll just go ahead and put E here. And a lot of times folks will just implement this as a friend function. So let's actually do that. That's probably one of the better use cases for friend here. So that we can actually access the if we have private member functions here, which in this case we don't, but I'm going to go ahead and just use friend again, just as a little bit of a review for some of the things that we've covered earlier in this series. And then this is going to look relatively the same. Here's our output stream, and it's a const edge e. And then what we'll go ahead and return from this, or our stream here, let's do e.v1, comma, e.v2, and then we're going to return this stream here. Now, we haven't really covered streams too much in this series. If you want to see some lessons on that, we will do that. I mean, it's basically a sort of singleton or a global output stream when we're using cout here that we're writing to. So that's the idea here. Let's go ahead and compile that, see if I made any errors. Looks like a few errors here, so let me make this a little bit larger here. And just a few little bugs here. It says no named type here. Let's actually just kind of scroll through and get to the bottom of this here. Basically, it looks like I just forgot to put standard in front of here. So that it actually is the type that we want here. All right, so just a few little corrections here, a few little reminders. And again, just not to panic here. Let's see if I got them all here. Let's give that a try here. Okay, and now we've got something here that can actually write out our edges here. Let me actually get rid of this end line here, then I'll be a little bit more happy with it. There we are. So now we can actually add our edge to our map and then display it here. Okay, so not too bad here. You know, one extra function to print things out here. A nice thing to do here. Now we can actually, I can show you the update here. So let's say updating our edge if it exists. Okay. And let's just go ahead and just kind of label this. We created our first edge here, edge 1. Display something that exists in our map. We took a little detour here to override the operator here, so we can just kind of print things out nicely. And then let's go ahead and rewrite out edge number 1 here, just so you can see the update that it is now 1, 1 here. Okay, so now the second time that we accessed it, we've actually updated this value here. Now let's go ahead and see what happens if I try to print out an edge that doesn't exist here. Let's go ahead and put edge 2 here. Let's see if it does something interesting. And it does, I should say, meaning that, you know, if I comment out this first print statement, just so it's clear what's happening, it will create that edge here. And it just happens that it put 0 and 0 in for our edge number 2 here. So we just kind of got lucky there in this sense here. So you do have to be a little bit careful here when working with maps here, because this will create an empty entry here. So probably what we want to do if we want to return something, and let's go ahead and look at our documentation here. If we're just accessing an element and we have bounds checking for what that's worth in our map here, we could go ahead and see. I mean, it might be interesting to see if we look up something that doesn't exist here. It looks like it will return a reference to the map value of the requested element here. That's if things go well. And so if the container doesn't have an element with a specified key, it looks like we're going to get an out of range exception. So let's just go ahead and play with those here. Let's modify our code here just to show you. If I look for edge 1 here with @ that's a little bit, that should be safe. That shouldn't change any behavior. Okay, there it is. And then our edge 2 here, which doesn't exist. Let's go ahead and see if we get some exception or weird behavior. Yes, we do get an exception here. That's probably what you want if you're just printing things out. So that's just something you can do. Now let's go ahead and actually create this edge 2 here. And let's do it with the standard template library. Let's look at some of the other functions we have. Our modifiers. We can insert a new element here. So let's take a peek at it before we do it. Already you can see there's a lot of different ways that we can insert into a map. Here's sort of the old way where you insert the actual value here. But let's go ahead and see if we can find some of these examples. So 1 through 10 here. Let's go ahead and scroll down to our examples. And again, the insertion time here, again, we're looking at logarithmic time, again, just to highlight that in the map here. And then we'll get to showing the order here once we have a few things ordered here. Okay, so overload number 1, let's go ahead and look at a few of these. Let's just go ahead and try some out here. So something I could do again is my map dot insert, and let's just go ahead and make a pair here. So I could use standard pair like we learned about last time. And using class template argument deduction, I think it'll be smart enough that I don't have to actually provide the key value pairs, but let's show it both ways. And let's go ahead and put in edge 2, and then we're going to go ahead and put in our edge. Now we don't really have a constructor here. Let's go ahead and just create one here. Edge, and it will take an unsigned long v1, unsigned long v2, and we want to initialize this properly. So v1 will take underscore v1, and v2 will take underscore v2 here. Okay, and then it could just be empty. Okay, so that's just a little constructor for our edge here. And let's go ahead and continue here, and let's go ahead and add for edge 2, let's add 2 and 2 again, just so we can kind of see things here. And let's see if that does our insertion. Oops, looks like we're getting a few different errors here. Let's go ahead and try to investigate here. Let's see, no matching function call, and let's go ahead and fix this up. Sorry, a couple bugs here. We need to provide so we've got our little constructor here, but I need to let's give a default constructor here. v1 equals, let's use the value -1 here, just so we know if it was sort of default constructed. And that should almost do the trick here. It looks like I forgot one parentheses here. But now we should be able to insert our next pair here. And here it is using pair, which we learned about previously. Now we could also use something like make pair. That would also be fine. And also give you some deduction capabilities. So, you know, in fact, that's probably, let's check the CPP reference and see if they use make pair. That might even be a better thing to do here. I guess not. Looks like they're just using standard pair to do the insertion here. But we could do that. Now, in this particular overload, it's interesting because we can see where the insertion is being done. And then they're using structured bindings, which is something I don't think we've talked about too much in this series. Might have come up here, where you can actually, it looks like return the, well, let's actually look at overload number 2 here. It gives you an iterator, and if this insertion was true or false. So we'll know where we inserted the actual pair and if it was successful. So that's kind of a neat trick that you can do here. Let's actually do that here, since we know this is a Boolean and then this is the iterator here. Let's go ahead and just make another. We'll just kind of replicate this example here. Let's go ahead and do that. Let's do my map.insert. Let's do make pair here. Actually, let's just stick to pair. I don't want to create too many bugs here as we move along. Let's give another edge here. I'll just be a little bit lazier here. 3 and 3. And then let's go ahead and return. We're going to use auto for type deduction. We'll get the iterator back and success. And let's just go ahead and write a message. Edge 3 was added. And let's just go ahead and print out success. I'm assuming it would be successful unless you run out of memory or something. So let's go ahead and try that. And edge 3 was indeed added here. You get a 1 here. So that's kind of a cool use here. So I'm going to put this as use a structured binding to return successful, and retrieve an iterator to where the element was inserted. Now, since we have this iterator IT, let's go ahead and get into that. We'll talk about iterators here. Let's go ahead and print it out here. And do IT. Let's just go ahead and print out IT if I dereference it. Let's see what that is. And it's going to give us, okay, a bunch of error messages here. Let's go ahead and see, because it probably doesn't like that type here. But let's go ahead and see if I dereference it. And well, let's see here. It's giving us an iterator to our actual map here. So we got to be a little bit careful. So we can't exactly print out that iterator. Maybe let's think about that for a second. And if it's giving us the pair, well, let's try to print it out. Let's try to dereference it again here. But we need the actual, let's see here, first element here, since this is a pair here. Okay, and that should give us edge 3. And I'll just go ahead and put a colon here. So was edge 3 inserted? And it was here. Okay, so we get a 1 here. Okay, so that's kind of nice here. I guess you'd want to check for success first before dereferencing this iterator, but anyways, that's the idea here. Okay, so now that we've added a few different things into our map, let's actually iterate through it here. Again, a couple different ways that we can do it. Let me show you the sort of classical way here with a for loop here. And yeah, let's just go ahead and we need a iterator to something that is of type string in edge. So iterator it, and that's going to equal my map dot begin. We've seen this pattern many times here. And we'll say, well, it does not equal my map dot end. We will keep incrementing that iterator. And again, since this is a key value pair, we will go ahead and print out. Let's just go ahead and print out everything. And we should see these in some sort of sorted order, meaning edge 1, edge 2, edge 3. Just to throw a little bit of a curveball in here, let's go ahead and create another edge here, create another edge, my map. Let's just call it edge 7 here, just so we can see how these get sorted. And I'll give it something like 7 and 7. And then let's go ahead and run this. And we can see that it is in fact in sorting them 1, 2, 3, and 7 in sorted order there. So perfect. So that is sort of the classical, iteration. Let's go ahead and use range-based loops, And we'll go ahead and use for here. Const auto, because we don't want to modify our elements. I'm going to do this by reference so that we're not changing anything. And then you usually do something like keys, and then our collection here, which is my map. And then I'm actually just going to grab this again here. And let's go ahead and look at each of our keys here. Now let's see, is this giving us the pairs, or is this giving us an iterator that we need to access the first element? Again, so if you get these sort of scary messages, usually working with key value pairs, we want to just get the first element here. Let's see here. Oh, base operand as non-pointer type. Okay, so let's go ahead and fix this up here. There we go. Now again, we have 1, 2, 3, and 7. And occasionally, of course, you might want to, just to differentiate these two, let's go ahead and do keys dot second. And I'll go ahead and put a colon here. And remember, we wrote or overloaded the stream operator so that we can just print out the edges here. So you can see this second time here. Now there's little neat tricks you can also do here if you want to use the structured binding like we did here. And since this is a key value pair, you could just do keys values. So you'll sometimes see this. Let me actually do this on a second line here. This is just another neat thing that you might see in some C++ code and other folks will do. So keys, values, let's just do keys and the values, okay? And go ahead and run that. And again, you'll see the same exact thing here, again, using that structured binding. So maybe I'll make a video on structured binding, structured bindings, because that's kind of a cool trick that you can use. All right, so with that said, let's go ahead and look at a few other things that we can do here. Let's go ahead and look at maybe erase here. But let's go ahead and do with contains and find. So let's see if we find something, then we'll erase it and then we'll iterate through it again. Let's do it before this loop here. So let's go ahead and say if my map dot contains, and we look up the key value pair here, edge 3, and that's going to return true or false. Then we're just going to do my map dot erase edge 3, and that's going to delete it. So in this latest iteration, we should only see edge 1, 2, and 7 versus our previous iteration 1, 2, 3, and 7 before we erased it here. Okay, so that's something that you could do to remove keys from your map. So let's do a few more little exercises here. I know this sample is getting a little bit long, but a few more things yet to show you here. Let's go ahead and on occasion, you're just going to see this in your code here. You know, let's say we have this pattern frequently show up where you need strings and edges for whatever reason, or, you know, your key might be relatively simple, but maybe it's storing a vector of edges or something. So you have some more complicated data structure. So again, don't forget about your things like using, and I'll just call this like string edge or something. And you could just do standard map, standard string of edge, and just kind of define that new type here. Okay. So again, you get the alias. So I could have string edge, for instance, replacing all this stuff here. Now, where can we use that? Again, in our sort of classic iterator pattern here. Let's go ahead and see here. So I could actually just replace this with the string edge iterator here. Okay, so occasionally you'll see that in your code just to clean things up a little bit, especially if you have lots of maps of, you know, more complex data structures. That's one thing. The other thing that I should probably show you before we wrap things up is to go ahead and show you if you want to use the key of some custom type. So let's just go ahead down here and create another map here. And this time, let's say that we want edges. So I don't know, you want edges of strings for whatever reason this time. And I'll call this my map 2. Let's go ahead and just see what that looks like if I try to, I can compile it here. But let's just go ahead and do my map, and let's just create an edge here, E1, with 2 different things here. And I want to use that as my key, and it's just going to equal, you know, test or something like this. Okay. So again, our key this time is the edge instead of the string. And, you know, we get this sort of wild error message that's showing up here. You know, again, one of many that I've created. But the idea is here, it's saying, you know, no match for operator, whatever here. Basically just doesn't understand how to break this down here. I mean, let's try to decipher this a little bit here. If I go into our operator here, and the idea, right, is we need some key here. And I think if we look through this carefully enough, let's see. Basically, the key has to be something that can be hashed here. Let me go ahead and see if I search for a hash, if I find it here. Yeah, it doesn't look like I found it here. But that is sort of the key to using a map data structure here. So let's go ahead into our utilities. Let's see how we can write that helper function here. So again, we'll find this under our general helper utilities here, the hash function. And for this, I'm just going to have to look for a sample here so that we can see how to actually implement this. And basically, you just have to write a specialization of the hash function. So there's a couple different ways you could do it. This is actually a nice one. I'm just going to probably grab this one here. So a couple different ways. If you're in a older code base, again, pre C++ 11, right, you don't have a standard hash here, so you can create a functor for your hash function that you'll provide into your map here. Now, where is this applicable? Where do we need a hash function? Well, do we need it for map? Well, let's go ahead and just take a look here. Actually, we don't need it for map here, so I jumped a little bit ahead of myself, but we will need it for unordered map. So let me just go ahead and show you for unordered map, we are going to need this here. And actually, I will just cut off this video before we get to it. And then in the next one, I'll cover doing the less than operator. Actually, let me do less than for map, because that'll be a little bit more useful. Then I'll come back and switch, and we'll do a separate video on unordered map, just to keep this on topic here. So for map, let's go ahead and do the less than, just like we did. Again, same thing for our set video. So let's go ahead and open this up here. And then for edge, and let's give ourselves the full real estate here. And we have to be a little bit careful. Let me see if I make the same mistakes here from the edge video. Let's give ourselves operator less than. And in order for this operator to work, we do need a less than. So again, we're going to return true or false here. So then leave that as is here. The type that we're comparing to is, again, our edge type here. That's const here. And I just call this usually the right-hand side here, and we need the const at the end here. Now, how do I determine if one edge is less than the other? Again, mathematically, maybe there's a way to define it. I'm just going to return if v1 plus v2 is less than rs, the right-hand side v1 plus right-hand side dot v2, then that will be the sorted order here, okay? Or we could actually, you know, reverse these or whatever. But with that, once I implement that function here, then we should, in theory, be okay. But we are getting a error message here. Now let's try to take a closer look at this. Okay, so we've got a bool operator less than. Well, it seems like I should be able to, you know, use that as my key, right? That's what the default is. So let's go ahead and take a look at our examples here. And let's go ahead and see. Okay, so we have some compare and, you know, okay, so it defaults to less than here. Well, there is a nice way we can actually just fix this, and we can just pass in the actual comparator function here. Let's try to just pull this out here. And again, you usually do this with a func door. And this is kind of nice. And there's sort of a reason for this. You know, creating these sort of policy-based designs here. I'm just going to call this edge compare here and wrap this in a function. And since it needs to be callable, right, operator with the brackets here. And then let's just go ahead and make this the const edge left-hand side and const edge right-hand side. There aren't any member function, so I don't need this const here, actually. And let's go ahead and do left-hand side, and then let's go ahead and so we use this as our comparator function, and I'll go down to the bottom here. And then when I create my actual map here, I need to look at edge compare here. So let's go ahead and take a look at that. And it looks almost okay. A few mistakes. Let's see, my map 2 here. Make sure we're using the right one. I think there's actually one mistake. I think I should have left that const in there. Yeah, it's going to say is invocable. So it's using traits here to make sure that I knew I'd make this mistake. This needs to be const here. Okay. So now we're able to run this again with a sorted order here. For our my map 2 here, and let's go ahead and give ourselves a few more edges here. Let's go ahead and insert let's see, 0 and 8 here as edge 2, and then let's iterate through it just so you can see that we get these here, test 1, test 2. So these should effectively be flipped in order based off of our search here. Let's use a range-based for loop here to print out my map 2, which again, for our keys and values, you should see this flipped here to have 0, 8, and then 8, 8 if our sort in fact works here. And it in fact does here. Okay, so you can see how we have that custom sort function. So a little bit of a real whirlwind tour, but hopefully comprehensive for map. I'll end it there. We'll talk about the hash function with unordered. A fun thing to do is to just go ahead and change map to unordered. Maybe I'll do that in the next video, and we'll just rebuild the same example. And then you'll implement the actual hash function and then swap it out for the compare, because we won't need that. But just to review here, again, we learned about the map structure, which is an ordered data structure. It's an associative container, so that's why we've been working with pairs here. And we looked at strings and edges. We looked at some ways to make it a little bit easier to work with the type. Some examples of how to insert and modify edges here. If we already have one in here, we looked at different ways to iterate as well, access the different pairs here. So here's our iteration strategies, checking for assignment or checking if something exists. You could use contains or finds, erasing edges as well. And then we looked at, creating our own custom function so that we could get a sorted order. Now, in order to do that, we passed in a comparator here. We made a little mistake of using the less hand sign, but that's really all we need to do with a functor. And then we tested this out here. So quite a bit in this lesson here. And I'd recommend, folks, I'll just go ahead and throw it up here. If you're following along in this series, make sure you check out the other STL videos if this was too much or too advanced, but you can track your progress in order to keep learning there. And with that said, I'll go ahead and end this here. If you have questions in the comment section, feel free to let me know. Again, a bit of a monster lesson, but hopefully showed you off most of the pragmatic stuff and some of the advanced stuff that you might be doing with the map. As always, folks, thank you for your time and attention.